So rewriting before integrating. So let's look at this example. So here we have a quotient, right? So we have the integral of x plus 1 over the square root of x dx. This is a quotient. But we have no quotient rule. So this is a problem. So this is why we have to rewrite this problem before we can integrate. So throughout our rewriting steps, before we actually apply our rule, every time we're going to have that integral symbol. So the first thing that we notice is that in the bottom, we have a square root of x. Symbols, we cannot integrate. So let's go ahead and rewrite that. Let's leave the top alone, x plus 1. And we'll divide by x to the 1/2. My 1/2s don't come out so great. 1/2. There we go. Dx. Now, when we have one term on the bottom and multiple terms on the top, that just means that everything on the top gets divided by the x to the 1/2. So we can continue to rewrite this and just write this as the integral of x over x to the 1/2 plus 1 over x to the 1/2. So I just split it up using the two terms that were on the top. And this only works if you have one term on the bottom. Okay, so make a note if that's something that you might not remember on your own. Then after that, what we can do is simplify. We can simplify each of these fractions. So right here we have x to the first divided by x to the 1/2. So we subtract those exponents. So we're going to do 1 minus 1/2. On the top of the second one, we don't have an x. So we just have this x in the bottom. So we're going to bring it to the top and make it negative. So when our last step in rewriting this, we would have the integral. 1 minus 1/2 is just 1/2. So we would end up with an x to a 1/2 when we divided these two things. And then we'd have a plus. We need to move that to the top, so we'd have x to the negative 1/2. And then we have our dx at the end. Now we have finished rewriting. We can actually apply our rules, integrate, and simplify. Okay. So from here, to integrate this problem, we still add 1 to our exponents and divide by that number. So 1/2 plus 1 will be 3/2, and we divide by 3/2, plus x to the negative 1/2. If we have negative 1/2 plus 1, 1 becomes 2 over 2, and we get a positive 1/2. So this is x to the 1/2 over 1/2. And we've integrated, so we need a plus c at the end. And then our last step is to simplify. So we want to simplify this. This fraction can flip, so we'll have 2 over 3, x to the 3 over 2. This fraction will flip. We'll have 2 over 1, x to the 1/2, and plus c. And then if you notice, 2 over 1 is just 2, so we can write that as a whole number. So we have 2 over 3, x to the 3 over 2, plus 2x to the 1/2, plus c. And if you wanted that x to the 1/2, you could rewrite this as 2 square root of x as well. You don't have to. That's not something that you have to do on your homework, but just know that that's how that could be rewritten and how you could write it as well. Okay. So I want to look at one more example here. So we have a trig problem. So we're integrating sine x over cosine squared x. So the problem is, again, this is a quotient, and we don't have a quotient rule. Sometimes, in order to split up these trig functions, we just want it to be one trig right next to each other. we need to use some identities. And we did use a couple of these when we were taking derivatives. Okay, so what's really happening here is that we're integrating, and we have sine x over cosine squared is just cosine x times cosine x dx. And really, on the top, we can say that sine x is times 1 because that doesn't change anything. Well, if these are all multiplied, we could just split it up into two fractions that are multiplied. So we can also rewrite this as sine x over cosine x times 1 over cosine x. Ooh, forgot the s. Basically, we just split it up right here and said times, one big times instead of two in the same fraction. And then I need my dx on the end. So if you know your trig identities, which you may not, you may need to review. Okay, this is important. The last thing that we can do to simplify this is that sine over cosine is tangent. 1 over cosine is secant. So if you notice this is tangent times secant, look at your integral list in your notes from yesterday. You might see secant times tangent, but remember, multiplication can always be flipped around because 6 times 2 is the same thing as 2 times 6. So this is also the same thing as integrating secant x times tangent x dx. And when we look at the integral of that, that's exactly on our list. The integral of secant times tangent is just secant x plus c. And that's it. Okay, so that was more about the rewriting. There's not really much simplifying once you've gotten to your answers for trig. So just to review that, take a second to look at it. I know we're not as familiar with trig, but it is important. There's some more examples of indefinite integrals. We call them indefinite integrals because we have the plus c, and we are not definitely sure what that is. So that's what we call them. So we're going to practice a little bit more rewriting before we can integrate. Okay, so it's a lot of algebra review. So we're going to do 6 examples. So our first example, we have the integral of 2 over the square root of x dx. Okay, so there are a couple things that we can do to rewrite this. Remember, times anything, that 2, we can just move it out front so we don't even have to worry about it right now because it's just going to be multiplied by our answer anyways. Okay. Then, if we do that, we still have 1 over the square root of x. So if we move that 2, we still have a 1. We have the square root of x, and we can't do symbols, so we're going to change that to a 1/2 dx. And we're still not quite ready to integrate because that x to the 1/2 is in the bottom, so we need to move it to the top, and how we're going to do that is with a negative exponent. So we have 2 times the integral. We move that up so we have x to the negative 1/2 dx. And that's what we can integrate. So when we integrate this, we will have the 2 out front times, and we'll do our answer. So we'll follow our integrating rules. So negative 1/2 plus 1 whole will make a positive 1/2. And then we also divide by 1/2. We took the integral, don't forget your plus c. So when we flip 1/2, we have 2 times 2 over 1. So we have the 2 out front, and then we flip 1/2, and it becomes 2 over 1. We have x to the 1/2 plus c. And then finally, we can multiply these. So we have 2 times 2, which is 4. Dividing by 1 doesn't change anything, so we can get rid of that. And that 1/2 we could rewrite as a square root. So we have square root of x plus c. And that's our final answer. You don't have to rewrite it with a square root. I just want to make sure that you know that that can happen. If you leave a 1/2 like in your homework, that's totally fine. So let's look at another example. So we have the integral of t squared plus 1, but it is all squared. So be careful here. When we're taking the derivative, if we were taking the derivative of this, it would be a chain rule. But remember, we have no chain rules, product rules, quotient rules. We don't have any of that with integrating. So what we have to do is undo whatever is there. So when we are saying that this is squared, we are saying that this is the integral of t squared plus 1 times the integral of t squared plus 1 dx, or dt, excuse me, because we changed our variable, so we're going to change that too. We're using t's, so we need to have a dt. So we didn't have a chain rule. We don't have a product rule. So what we need to do is multiply this out. So we have the first two terms, the outside, the inside, and the last. So we need to distribute the t squared, distribute the 1. So when we do that, we have the integral. T squared times t squared is t to the 4th. T squared times 1, we'll have just t squared. 1 times t squared, we have another t squared. 1 times 1 is 1. We're using dt's, so we have dt at the end. And then finally, we can combine those like terms in the middle. So really what we're integrating is t to the 4th plus 2 t squared plus 1 dt. So now we can actually integrate this, and we just go through and add 1 to the exponent and divide. So we have t to the 5th over 5 plus 2t, add 1, we'd have cubed over 3 plus 1t to the 2nd, excuse me. No, it's 1. T to the 1st. I was right the first time. 1 over 1. What happened? Changed my color. And that's the end of the line, so we have plus c. And then we can simplify this answer. I gotta move this one down a little bit. If you wrote your final answer like that, that would be fine. I just want you to know that it can be simplified. So this could be written as 1/5 t to the 5th. And this could be written as 2/3 t cubed. That can just be written as t. And then we have plus c at the end. So either one of those last two would be fine as your final answer. I just want you to be aware of what could happen. Okay. So let's look at our next one. Oops. Okay. So we did one like this in the last video. So this is a quotient, but we don't have a quotient rule. Okay. But we do have one term on the bottom. When we have one term on the bottom, we can just divide each one on top by that term and split it up. So when we split this up, we're not integrating, so we still need an integral. And we'd have x cubed over x squared plus, and then my other term is a 3, and that's also going to be divided by x squared. We're back to x's, so we have a dx. I still can't integrate this. We still have some fractions. So one more rewriting. And so x cubed divided by x squared, we subtract those exponents, and we get the integral, so it's just x to the 1st. And then this one doesn't have any x's in the top, so it's just 3 is our number, so we need a 3 out front. We move this x squared to the top, we make it negative, x to the -2 dx. And then we can integrate it, so we're ready to follow through with our rules. So when we do that, we have x squared over 2 plus 3x to the -1 over -1, because when we add 1 to -2, we get -1. And then we're done, so we have plus c. And then we can simplify this one, so our final answer, you can write it as x squared over 2, or you can rewrite it as 1/2 x squared. Dividing by -1 will change our sign, so we'll have -3 And then the x to the negative 1 could move to the bottom. So over x to the first, which we don't have to write if you don't want to, plus c. Okay. Let's do a few more. Okay. This one is one where our exponents get a little tricky. So when we have this, the first thing that we have that we cannot do is a symbol. So we need to rewrite that. If we have a cube root, we rewrite that integral as x to the 1/3. And that is times x minus 4 dx. Now, we still don't have a product rule. So what we're going to have to do is distribute this x. But right now we have x to the 1/3 and x to the first. That really has a 1 there. When we multiply x's, like if we had x cubed times x squared, we would add those exponents and we'd get x to the 5th. Okay. So even though these are fractions, our rules still apply. So what we're going to have to do when we multiply x to the 1/3 times x to the first, we're going to add. So 1/3 plus 1. So that'll be 1/3 plus 3/3, which is 4/3. This is still just rewriting our integral. So in order to rewrite our integral, we'll still have our integral symbol. And when we distribute this, we said we're going to add these exponents, and we added them, so it's x to the 4/3, x to the 1/3, and negative 4, so those just get written in a line together, 4x to the 1/3, and we have dx on the end. Now everything is good. I have no symbols, I have no product rule, no quotient, no fractions, so I can just add, I can just do my integration. So we're going to add 1 to this exponent. So remember our shortcut is 3 plus 4, so it'll be 7/3 on x, and we divide by 7/3. And then 1 plus 3, so this will be minus 4, and we'll have x to the 4/3 divided by 4/3. We get to the end, and we have a plus c. And then the final step, we'll simplify this. So that needs to move a little bit. Whoops. So we have, let's see, flip this fraction. We have 3/7, x to the 7/3, minus, we have 4 times, we flip this fraction, 3/4, x to the 4/3. And then one more thing can happen. We have a times 4 divided by 4. Those can cancel. So our final answer, 3/7 x to the 7/3 minus 3x to the 4/3. And then plus c at the end. A couple more examples just to practice a little bit more with negative exponents. So that's E. So this one, we have a 4 on top. So really, when we're integrating this, what this means is just 4 times the integral of 1/x cubed. Okay. So when we look at that, what's happening before we have to integrate, this x in the bottom is a problem. So we need to move it up. And how we can move it up is with a negative exponent. So we still have 4 times the integral. Now it's x to the -3 dx. And now we can integrate this. So we do our rules. So we have 4 times, the 4 is just out front, along for the ride. Add 1 to the exponent, we have a -2. Divide by -2. And plus c. And then these can be divided. So 4 divided by -2. So when we do that, we have -2. X to the -2 plus c. You could leave your answer like this, or the one more thing that could happen, we could have negative 2 over x squared plus c. And then our last example. Be careful with this one, because it is a group on the bottom. We cannot just do 2x to the negative 3 and integrate that, okay? So don't do this. What we need to do first is actually use that exponent. So when we do that, we have 1 over 2 cubed is 2 times 2 times 2, which is 8. X cubed, we just write as x cubed dx. So the number that we have in front is actually 1/8. And then we still have 1 over x cubed. So what is happening is our number out front is 1/8. We still have 1 over x cubed dx. So there's still one more thing we have to do to rewrite this. We have 1 over 8 times the integral of x to the negative 3 dx. And then from there, we are all ready to use our integral symbols. So we have 1 over 8 times, so just leave that, it's long for the ride. Add 1 to the exponent, negative 2. Divide by negative 2 plus c. And then there's a couple different things you could simplify here. Remember, for an FRQ, stop there, you're done. But we can multiply these two things on the bottom. So we have 1 over negative 16 times x to the negative 2 plus c. You could leave it like that, or the last thing that could happen, this negative exponent could move down to the bottom. We could have 1 over, so this would be a negative, because that 16 is negative, x squared moved down, plus c. Okay, so either one of those last two would be fine for like homework and all that kind of stuff. All right, so that is the end of this video.